Hey guys, Kenna here. So today we're going to go ahead and take a look at natural gas. We've already gone over oil, and so the next step is to go ahead and take a look at natural gas. Now, remember that natural gas is going to be cleaner than oil in terms of the environmental impact, in terms of the greenhouse gases, but that doesn't mean it's clean. Okay, so let's go ahead and look at our essential questions and jump right in. Number one, what is natural gas? Number two, what impact does the production to use ratio have on available future resources? And number three, what are LNG and flaring, and how does this relate to the availability of natural gas resources? Now, the major component of natural gas is methane, CH4. There may be other gases present, however, and this includes ethane, propane, butane. And if you ever buy those gases, those are typically refined off from the original natural gas. So you may have a propane heater, or I know when I go camping, I have my propane stove that I use for our cooking. And I don't know if most people don't smoke anymore, but the old Zippo lighters, those were butane. And so when we go ahead and start thinking about all these different fuels, these are just the gaseous form. So oil is the liquid, coal is the solid, and natural gas is the gas form. Okay. So the first thing we want to take a look at is again formation. Now this is thermogenic, which means it's converted into an organic material from in the form of gas due to very high pressures. It's basically formed the same way that oil is, just with greater pressure and greater temperatures. Typically, we have a deeper window than for oil, and it's biogenic as well because it's from the transformation of microorganisms. So, what's it made of? It's primarily made of methane and other light hydrocarbons, but it can be a mixture of 50 to 90% by volume of methane, propane, and butane. We have what we call dry and wet versions. That depends on the methane content. And we have sweet and sour, which depends on the sulfur content. Now, usually it's found in association with oil. Okay? Formation of oil is likely to have some natural gas as a byproduct in those areas where there is greater temperatures and pressures. And so it's often layered above the petroleum. Okay, again, that should make sense because in terms of our density, the gas is going to be less dense than the liquid is. Now, world natural gas consumption is expected to increase by about 43% from 2015 to 2040. And this is largely because of growth in what we call non OECD, or Organization for Economic Cooperation and Development countries. So we're seeing an increase in the drilling and access of natural gas by companies that are not part of this OECD group. Okay. And so while the volume is going to continue to increase for everybody, you're going to see a faster increase in those countries not part of that group. The leading producers of this natural gas are Russia and the United States. Um, and so you can see from this map, you can see that there are several countries that produce natural gas, but most of them are in limited quantities when compared to that of the United States and Russia. And compared to what we've seen with oil, the reserves are a little more substantial. Um, we have reserves that are likely to go ahead and satisfy our energy needs for at least the next 100 years. There are some areas that have pretty high concentrations. Currently, 45% of the world's reserves are found in Russia and Iran. Okay. We do have regional concentrations of gas, but it's pretty spread out, surprisingly. Unlike oil, where you have a ton of it in places like the Middle East, natural gas reserves are a little bit more spread out, but there are definitely still areas like the Middle East again, because that's where the petroleum is, that you're going to have higher reserves of natural gas. And so only 36% of the reserves are actually found in the Middle East. If we take a look at a map, you can see here that we have large reserves in the Middle East, obviously, but we have some in Africa and South America, North America, Asia. We even have some in Europe and Australia. Okay. If you take a look, we can take a look at reserves versus production. Okay. In North America, we are producing a lot more than we have in reserves. So our supply is going to diminish. But if you look at places like Eastern Europe, in the former Soviet Union, you have the Middle East. These are areas where the reserves still outpace production. And so they're going to have natural gas available for longer. You take a look at places like Western Europe, they're outpacing their reserves. Asia and Oceania are outpacing theirs. Africa actually has more reserves than use. And Central and South America are pretty level, maybe a tiny bit more reserves than their usage. So, how do we use natural gas? Now, the first thing I want to point out is while we talked about oil being primarily for transportation, and we haven't got there yet, but coal primarily being used for electricity production. One of the cool things about natural gas is that natural gas is pretty diverse. Okay, it can be used for a variety of different applications. Definitely used for electricity generation, but also for heating, also for transportation. So it's a little bit more flexible in what it can be used for. Um, Most is used for energy generation, however, and previously it was often wasted or burned off when we were trying to extract oil, but now we've realized that if we can harness it, we actually have another valuable fuel. Of all of the fossil fuels, it is considered the cleanest to go ahead and use. The biggest problem is transporting a gas as opposed to transporting a liquid. And this typically is going to require pipelines because it's not something you can just pump from one place to another easily. Also, gas turbine technology enables us to use natural gas to produce electricity far more cheaply than it is to use coal. So, coal is fairly polluting. And so, regardless of what you've heard, even about clean coal, it's fairly polluting. And so, it's actually more cost effective to use natural gas, and it's cleaner for the environment than either oil or coal. Now, most of what you think of when you hear the term natural gas is going to be what we call liquefied natural gas. Because it is so hard to transport a gas, we cool it down. And so we cool it down and it loses a whole bunch of its volume and it becomes a liquid, which makes it super easy to transport. Well, sort of super easy to transport. I say that because while the liquid itself is much easier to go ahead and move and transport and keep together, it has to be really, really cold. And so now you've got the limitation of how do you keep it cold during transportation. So when we're trying to go ahead and get it there, we have the extraction process of how we get it out. Then we have to do the liquefaction of turning it into this cold product, which is requiring energy. Then we have to ship it, which requires energy. And then we have to store and regasify or convert it back into the natural gas format. All of this costs energy. And so if we think about that net energy concept we've been talking about, this has to play into your analysis. Now, when you get to a lot of oil drilling sites, they have what's known as burn off. And the process of burning off that excess natural gas, uh, again, not really even used, is called flaring. And this is when they burn it straight at the wellhead because they don't have a method by which to capture it. And that methane, as it's burned, creates greenhouse gas effect. And so there's problems when we start looking at how we go ahead and produce oil and the waste product. I don't want to say waste product because it's definitely usable, but the unused portion of natural gas that's flared off from that process. So let's take a look at US gas growth. Okay. Now, shale resource development accounts for about 50% of the US natural gas production as of 2015, and that's expected to increase to about 70% by the year 2040. This growth is mostly due to the country making advances in fracking techniques. And we talked about fracking last class. Okay. So when we start looking at fracking, remember, requires all these additives, pumping all this water into the wells and pumping it in to the point where it actually cracks and breaks the rock. That happens, and then we've got these proppants, which are going to go ahead and be either ceramic or sand or something to keep the cracks open so that the gas can go ahead and leach out. Um, Remember, as I mentioned earlier, natural gas is a mixture of gases. We've got ethane, we've got butane, we've got propane, but about 50 to 90% is typically going to be methane. This is more plentiful than oil, and it's much more versatile, as we mentioned. Cooking, heating, industrial processes, motor vehicle fuel, power for turbines, and it has a pretty low production cost overall, giving it a medium net energy. This is, of the non-renewables, probably the cleanest burning. Outside of nuclear, we'll talk about nuclear a little later. Okay. So U.S. production is going to primarily come from fracking um, in our shale rock layers. So deposits are often found above deposits for crude oil, as well as in tightly held deposits between layers of these shale rock that we find. Propane and butane are typically going to be removed first, and then LPG, which is used in rural areas not served by pipelines. And the remaining gas then will be purified, pumped into pipelines, and delivered over land and by sea as liquid natural gas. But remember that there is definitely an energy cost to converting it into a liquid and then to transport it, keep it cold, and then turn it back into a gas. However, with most of the fracking in the United States, most of the natural gas in the United States coming from fracking, we have to keep in mind the impact of the fracking process, not only on production of the resource, but also in terms of its environmental impact. When we start looking at drilling wells, remember there's a huge amount of water, sand, and chemicals that are utilized in the fracking process. And when we're finished, we have to somehow deal with that toxic wastewater. And we still have to transport the natural gas. Fracking has harmful environmental effects, which include water issues, polluted wastewater, gas contamination, air pollution from methane emissions that are lost, and with our rise in earthquakes in the general area, it destabilizes the underground rock structure because of the fracturing process. So, we have to keep all these impacts in mind when we start looking at our cost benefit analysis to see whether this cleaner burning fossil fuel is worth the time and effort. And I think some of that's going to end up depending on, how much we're willing to move away from oil in particular, but how well we invest in other energy sources, especially cleaner renewable energy sources over time. But one of the nice things about the natural gas market and fracking in general is that because we have supply here in the United States, we are going to be less dependent on countries, especially those in the Middle East, that may control most of the petroleum. Okay. All right. So when we start looking at consumption, production, and reserves, the United States is the world leader in natural gas production. We also are the world leader in natural gas consumption. But you'll notice that we are not in the top three when it comes to natural gas reserves. So when we start looking at these graphs, you can see that countries like Qatar have a strategic advantage because they have large amount of proven gas reserves and they don't make the top three in terms of production or consumption. So there's a potential resource for them in the future. And this data actually dates back to about 2014. So I wish we had something a little bit more recent, but that gives you a good example of the use, production, and reserves. And notice that China makes that top three in terms of production and consumption, but it is also not in the top three in natural gas reserves. There are other forms of natural gas that can be utilized. We talked a little bit about tar sands and talked about these heavy crudes when we were talking about oil. These are not the ideal form of the resource, but they are ones that are still potentially usable. Okay. We can find ice saturated with natural gas on the sea floors. And this is typically found in colder areas. We can also find it in Arctic permafrost. Um, we can get these, what are called methane hydrates, out. Okay. And when we get these methane hydrates out, we're essentially finding an unconventional source of natural gas. Very similar to when we start looking at the unconventional process by which we obtain natural gas now through fracking. So, if we're looking at natural gas as a whole, whether it's through methane hydrates or through the traditional extraction, and in the US, remember that's mostly fracking, we have to compare the pros and cons. What are the advantages and disadvantages? Well, the nice thing is globally, we have a pretty ample supply of natural gas. It's an incredibly versatile fuel. It can be used for electricity, for transportation, for heating. So, a lot of options. It has a medium net energy, which is not great, but it's better than a lot of other resources. And burning it emits fewer air pollutants than oil or coal does. What are the biggest disadvantages? Especially for LNG, we have a fairly low net energy. Um, Production delivery leads to an increase in carbon dioxide and methane emissions. And fracking, remember, which is the primary way we extract it here in the United States, has a lot of potential for pollution because we end up having that fracking fluid, which is a difficult wastewater for us to go ahead and dispose of. And that could potentially leak into the groundwater, which means what you end up drinking. Okay. All right. So that's what I've got for you. And so stay healthy, stay safe, take care of yourselves. If you have any questions, please don't hesitate to come see me, and we'll see you again soon. Take care. Bye.